I did this Muon optimizer research and I found out that it's actually better than AdamW, especially as we scale the size of the LLM. So in the first experiment, I tried searching for best learning rates for both of the optimizers, and we see here that AdamW has a specific learning rate that it's very good at, but Muon has a lot wider range of learning rates, so it's more robust. So I found that 0.01 was the best learning rate for Muon, but other ones are actually good as well, which will later show in the second experiment, where due to wrong learning rate, AdamW fails, while Muon doesn't, because Muon is more robust. You see here accuracy on validation, and across all of these learning rates, Muon works, while AdamW just works across these two or this smaller range. And this could also extrapolate further. Maybe Muon would tolerate even more learning rates, but that were not tested in this experiment. And I'll show you these graphs as well. They show the same thing on validation loss and validation perplexity here. These are the two learning rates that I found, so 0.003 and 0.01. However, they might differ based on batch size and maybe model size and stuff. We can see that in this second experiment. The tiny model, 11 million parameters, actually AdamW performs a bit better. The blue one lost slower, so it's a bit better. Although training accuracy is the same here. But as soon as we go from 11 million to 29 million, Muon performs better. And then increase to 15 million parameters, Muon performs even better on this LLM. So the LLM was just next token prediction, and there is code and everything explained. So this is the problem that we got. So I think the batch size or the model size was too big here, that Adam completely failed here actually. And Muon showed to be more tolerant to variations. Here we were not able to use same learning rate for all of the AdamW, because AdamW here failed with the same learning rate as the tiny model, for example. But Muon worked on all of them with the same learning rate, which means Muon is more robust and large training accuracy. Let's go back to the GitHub repository. So here, Muon Optimizer Research, so it's my name, Vuk Rosic / Muon Optimizer Research. You have the results, which is just first experiment. We have images and the report text files and stuff, and second experiment as well. Then you have README, which is just explaining the experiment as well, and you have Chinese version of README here. And then we have this Python notebook or Jupyter notebook, so you can download it here, and you can so here we have all of the code, and then we have this PDF file, which is this PDF file that I was showing to you, that shows the research, although kind of summarized version of the research, maybe even better explained or just summarized, is here in the README file. And lastly, this is just text LaTeX file that I generated the PDF research with, so you don't need this actually, but I'll keep it here. You can now rerun this, recreate results, or continue to do your own research. So the first experiment I ran on Google Colab, but the second one I ran on Novita AI RTX 4090 GPU graphics card. You can get this card extremely cheaply for just 18 cents per hour, which is, I think, the cheapest in the whole industry. I've never seen anywhere cheaper than this. So if you want to do it on Google Colab, you need to, for the second experiment you'll see in the notebook, you need to actually reduce the size. So you can copy this into Claude and ask it to reduce the size. So now I will show you how to run it on Novita. So Novita gave me free credits to run these experiments, but I'm telling you, you can get the cheapest card in the whole industry that I know of right here, this 4090. So I will show you how to do it. First of all, this is my affiliate link. So I just get 10%, you don't lose anything. This is a way for you to support me. So that Novita will give me 10%, so it's not gonna cost you anything more. So you can consider this a donation. If you buy some credits on Novita, I will just get 10%, so you can help me this way. So when you create an account, you click on create a new instance, and then you will get to this point. So you see you have a bunch of different GPUs, but if you see here filter and you change from on demand to spot, so you get a 50% discount on this 4090 card. This is because this is only available when they have free cards. So when people are not using, they put these cards on discount, so people start using them. But don't worry, they will give you 1 hour advance warning when they are going to take away your card. That's why they are giving it on discount, so they can take it when they need it. But you will have at least 1 hour to use it, and we don't need anything more than 1 hour. And you can also have more than 1 hour if nobody needs the card. So our research in this video takes a lot less than 1 hour, so we can just click deploy here. And here we can change template. So I will use this one because this one has this Jupyter Notebook interface. So I will just click here, you need to enable this. And then next. And we will say spot here and then deploy. While that's deploying, we need to download. Either you can clone this repository, or if you click here onto notebook, you can just download the notebook here. Okay, so you will need to upload this notebook. And if you are interested, everything in README file is kind of simplified version of the whole paper and a bit summarized version, so you can check all of the stuff here that I discovered. Once your instance is up, you can click connect and connect to Jupyter port here. So make sure to enable the Jupyter Notebook when you are setting up the instance, so you have this. You can also log in through SSH. I will not show you how to do it in this video because I was doing my research through Jupyter Notebook, so it's easier for everybody. But you can actually connect this GPU to your own like local workspace, to your VS Code and environment. So you don't need to use Jupyter Notebook. You can just open everything like this and have like this AI stuff on the side and code into this, which may be even simpler for some people. So first, you will not have anything. So make sure you are in workspace here. And then click here and upload the notebook that you downloaded. And here you need to install this. And after you install that, you need to restart the kernel. So you will go here, kernel, and restart kernel. Okay. And then you will install this stuff. And then you will install this stuff as well. I'm sure there is maybe a way that I can create an image for you, so you can just, like, you get all of this automatically installed, but I don't know how to do that yet, so maybe in a different video. But after you install this PyTorch, you also need to restart kernel as well. Okay, so this should take maybe like 15 minutes in total. And then you can just run. So you need to have 2.7. So check that. If you don't have 2.7, try restarting the kernel. Maybe you forgot or something. The first experiment is here. You see how it runs. It searches for all of the learning rates. And these are the most optimal ones. And second experiment is here. You just run this, click this run button, and it's gonna train a bunch of models here actually. Here, this will take maybe 40 minutes or less, maybe, I don't know. And that's it, and then you get the outputs. And you will get these results generated, the results folder. You can enter. And I think there should be a way, I think I have in my notebook, I have a way to download these automatically, or you can download them manually, like this, and download each of them. And then you can put them into like Claude to generate a report. But don't put this one, this raw data. I think it's too big, not necessary. So just put report and the images, not raw data. I don't know why I'm generating this even, but let it be there. Also, if you want to download this automatically, you can ask ChatGPT. It's a short snippet of code how to do it. So that will be it for this video. Thank you for watching. You can continue doing this research, maybe start this repository, and see you next time. Check out my channel for more of these videos if you are interested, and See you next time.